I'm going to address one of the things that separates DeJitter It products from every other product in the market. As digital devices, as digital chips draw power, they don't do it in a simple, even manner. Every bit, every byte, every operation that these chips do, millions of times a second, sometimes every few seconds, in a very complex way, each thing requires a small amount of power. What all the manufacturers that I've encountered do is for their chips, they just give it basic power and they kind of ignore the whole problem because it works. This doesn't result in the best performance. What we're looking at is I am playing a file off of the NukeX server, and we're in the dark right now in here because getting a picture of an analog scope is a difficult thing to do. What we're looking at is power. So at the very bottom is no power, and then as something goes up, it draws more power. So what we're watching is the NukeX power supply power to all of the chips and the systems, the subsystems, the CPU, the RAM, the SSD, the Ethernet, the USB, all of that. And we're watching how it does it. So you can see that there's a tremendous amount going on. Lots of little tiny pulses, bigger pulses, big jumps. There's all sorts of things that are going on here that are quite complex. Now, what I'm going to do is I'm going to zoom in so we can look in closer at what's really going on. So here you can see that there's something that's drawing real tiny little spikes close together. There's a lot of stuff going on in the background. There's bigger things that go on and off, and level changes. Things are fairly periodic. Some things are not periodic. There's a lot going on here. And the closer you look, the more complex all of this really becomes. So, addressing this, if your voltage regulation to your chip isn't feeding all this properly, then what ends up happening is the voltages creating these signals that we need on the buses and on the output on the USB, on the Ethernet. All of these signals are inaccurate because the voltage is varying because the regulators are not taking care of all this live and quickly. All of this ends up as noise, not only on the signals themselves, on the buses, on everything else, but the noise radiates out onto other parts, other PC board traces, and even inside the chips to other sections of the chips. So making sure that all of the power requirements, microsecond by microsecond, are fully handled is really, really important. And this is where I live. I really live in this whole environment to really make sure all this is done correctly. You can see that these variations sometimes are incredibly slow, so very low frequency, all the way up into microseconds, so all the way up into megahertz range. So this entire range of current draw has to be handled properly. So the voltage regulation needs to be extremely wide band and really, really accurate. Very few people in the audio industry address any of this. They address some of it using very basic methods, but not complete methods. Like, you go look at CPUs and RAM and all that, and you just don't see the power supplies to those chips being dealt with properly. This is controlled. If you go look at some of these chips directly, the mess is just unbelievable. So this is something that separates. This is why a NukeX, a little small NukeX, can sound so much better than much larger, much more expensive devices, simply because I've addressed something that other people have completely missed. Looking at the bus signals, looking at how everything communicates, addressing these issues really makes a difference on all of those signals, because all of those then become reference. They become very low noise. It's very important. So I just wanted to kind of show some of where I live and some of the work that I do and why I do this. This really is kind of interesting to a lot of people because they don't realize how much is really going on inside their digital devices, just how analog their digital devices truly are. And I'm addressing all of that analog aspects of these digital devices properly, really taking care of what needs to go on. Anyway, so what I'm using, let me bring up lights so we can look. So all I'm really doing is I'm using the NukeX, and I'm running a DA file, and I'm just playing some Alan Parsons. So that's what we were looking at, is we were watching the NukeX draw power and how it's doing it, and how it's being properly addressed.